I cannot begin to express how important naming compounds, ionic compounds, is. Important for this unit, important for your final, but in the second trimester of chemistry you will be doing this just almost on a daily basis in some units, and it's just going to be expected that you know how to do that at this point. So this is really something that you need to learn how to do. If you're struggling, if you need help, please ask. I cannot stress that enough. Some things that you're going to need besides your notes: definitely are going to need a periodic table. You are also going to need your little polyatomic ion sheet. And please feel free to pause during the examples, try it yourself, and then listen to the explanation and the answer, and double check that if you're right or not. All right, let's go ahead and get started. Binary compounds, we're going to start with those. Those are made up of just two elements, a metal and a nonmetal. So binary, that prefix means two. And some steps on how to name these. First of all, you want to make sure that you only have two elements, and you can check on your periodic table, make sure one's a metal, make sure one is a nonmetal. That's important when we get into covalent bonding. You won't have a metal and a nonmetal, so we want to be able to tell them apart. If your metal is not a transition metal, or if it's Ag, Cd, or Zn, silver, cadmium, or zinc, those are the exceptions, then you just want to write down the name of the metal, the name of that cation, the way it is on the periodic table. That's all you need to do. If it is a transition metal, so if it's in that big block that we labeled as transition metals that need Roman numerals, or if it's Sn or Pb, tin and lead, then you want to add the parentheses, and you're going to put a Roman numeral in there, and I'll show you how you can figure that out. The name of the nonmetal, that one just needs change. Remember, we take the ending off and we add the IDE ending. Now, to figure out the Roman numeral, we'll do some examples with these. You want to look at the ratio of your plus charges to your negative charges, because when you have bonded these together, that means that they've bonded together so that each can fulfill the octet rule. So your charge should add to 0. It should be neutral or balanced. So you want that Roman numeral charge to balance out whatever the negative charge is. Alright, let's start with some examples, and we're going to walk through these rules together. So we're going to look at this CS2O. We want to make sure that there's only two elements, which there is, CS and O. We also want to make sure the metal, is it a transition metal or not? If you look at CS, it is number 55. It is not a transition metal, so therefore it does not need Roman numerals or parentheses, and we're just going to write down the name of it the way it is off the periodic table, which is cesium. And then we want to look at our nonmetal. O is oxygen, but we wouldn't say cesium, oxygen. We have to take the oxygen and take the ending off, add IDE, so it becomes cesium oxide. Okay, as we go through these examples, feel free to please pause, try some on your own, and then come back and double check your answers. So if we move on to the next one, we have SRF2. Again, we only have just the two elements there. We also want to check our metal. Is it a transition metal or not? And if you look up SR, it is not. It is number 38. It is in family number 2. And so it does not need parentheses or Roman numerals. So it's just going to be written from the periodic table, strontium. And then our F, we know is fluorine, but the nonmetal, we change the ending. So fluorine becomes fluoride, and we have strontium fluoride. That's the name of SRF2. Alright, let's get into another one. We have CuO. Now for this one, we still want to make sure that we have two metals, or sorry, not two metals, two elements. We have copper, a metal, oxygen, a nonmetal. And then we want to look and check our metal. Is it a transition metal or not? And copper, Cu, number 29, is. It is a transition metal. It is not one of our exceptions of silver, cadmium, or zinc. So this one is definitely going to need the Roman numerals. We're going to write those in. We'll come back to figure out what goes in the parenthesis, but we definitely are going to need a Roman numeral. Your O, we have oxide from up here. So we know that the O is just going to be oxide. So this is what we have so far. And now we need to figure out how do we know what this Roman numeral is supposed to be. So to determine the charge, we want to look at our ratio, how many coppers and how many oxygens, because we want to be able to balance our charges out. We have 1 copper and we have 1 oxygen. Our unknown charge is on copper, and our oxygen, we know from our periodic table, is in the -2 column. And so you can see that in order to balance this, you need a +2 to balance out the -2, so everything adds up to 0. Mathematically, those of you that like to just do this simple math, this will always work. We know that we have 1 unknown, we have 1 copper element, and when we add the negative charge to that, it all needs to balance to 0. So we have 1 oxygen, which we know has a -2 charge. So we're adding our plus charge and our negative charge together, and that should equal 0. So x, we know that 1 times a -2 is -2. So x minus 2 equals 0, and that means our x, our unknown charge, has to be 2 in order for them to balance out. So our final answer would be copper with a Roman numeral 2 in the parentheses, oxide. All right, let's look at Ag2O. Going back to our rules, we need to have 2 elements. We do. We need to make sure, do we have a transition metal or not? We have silver, number 47. It is a transition metal, but you should have it marked as one of your exceptions where it does not need the Roman numerals. So even though it's a transition metal, it's one of our exceptions. O, we know we changed the ending from oxygen to oxide, so this is just simply silver oxide. All right, what about SnF2? We have Sn, we know, is tin, and if you find tin, number 50 on the periodic table, it's not a transition metal, but it is one of our exceptions that we said needs Roman numerals. So we are going to have to put the parentheses and change the F for fluorine. We need to change it to fluoride. So we have the tin, parenthesis, we'll figure out what the Roman numeral is, fluoride. And we need to, again, go through that whole process of what does it take to balance this out. I really like doing the math approach because it always works. We have 1 of our unknown because there's I'll pretend 1 here with tin. And when we add up the charge from our negative, it should balance to 0. Now we have 2 fluorines in this case. Each fluorine is in the -1 column, and that has to add up to 0. So x minus 2 equals 0, and that means that x has a charge of +2. Your notes are going to go through and explain all of that too, how we have the ratio of 1 tin to 2 fluorines, and then tin has to have a positive charge, a +2, to balance that out, and so tin 2 in the parentheses fluoride. PbS2. Here's another case where we have one of our exceptions. Pb is lead, and it is not a transition metal, but it has the Roman numeral because it's one of our exceptions. So we have lead off the periodic table, sulfur becomes sulfide, and then we need to figure out what the Roman numeral is. And again, the math will always work. So we have 1 lead. It is an unknown charge. We do not know. But we know that if we take our 2 sulfurs and kind of add, we need to get the total negative charge here. Each sulfur is a -2. That your plus charge and your minus charge have to add up to 0. So X, which is our unknown lead, has to be a 4. It has to be a +4 to balance out the -2 and the -2. And so your final answer, the 4, gets written as a 1 and a V. So lead, Roman numeral 4 in parentheses, sulfide for your final answer. Now let's look at polyatomic ions. There's really not a lot of difference when it comes to these. So first, the biggest problem is recognizing that you have a polyatomic ion. Let's say, for example, you have Li and then Cn. You need to notice that there are 3 elements there. And there will be someone, I'm sure, until we practice this, that will write out lithium, carbon, nitrogen as the name. And that is not correct. The names will only ever have the 1 positive half and the 1 negative half. You cannot have the 3, don't write out the names of each individual element. So you need to recognize that Cn is on your little half sheet of polyatomic ions, and so it has a unique name. And we're going to follow the same steps as we did before, where we have the cation. If it's a polyatomic ion, we just write the name down. We're not going to change any of the endings. So for instance, if we have sulfate, which is a -2 charge, we don't change it to sulfide because that's just S. Sulfate stays as sulfate. So polyatomic ions, you do not change the endings. Those are the way they need to be written. Alright, let's get to an example. First of all, you need to notice that you have 3 different elements here. So that means that you have a polyatomic ion, and you need to figure out which polyatomic ion you have. This ClO is the polyatomic ion. If you look at your little half sheet, you're going to notice a name for that one. Following our other rules, we need to find Na on our periodic table. Is it a transition metal or not? Sodium is not, so it does not need Roman numerals. We just write down sodium. And then we look up the ClO, and on your little half sheet there, it should be called hypochlorite, ITE ending. So we have sodium and then hypochlorite for the -half there. Let's go through 3 more examples and we're done. We have Mg3, PO4s in parentheses with a 2. Now if you have the parentheses there, that's a big ding 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 moment that you have a polyatomic ion. Parentheses will be used in some cases. So Mg, we look that up on our periodic table. It's number 12. It is not a transition, so it does not need Roman numerals. We're just going to have magnesium. PO4 is phosphate, and so our name is magnesium phosphate. If we do another one, we have the NH4, and it's in parentheses with a 2, and then C2O4. Now you've got a lot of stuff going on here. We have 4 different elements being used. We know that NH4 is in parentheses, so that's going to be 1 polyatomic ion. And then we have the C2O4 is another polyatomic ion. So both of these come off of your little half sheet there. And we never change the endings of any of those. So we have ammonium and then oxalate for the C2O4, ammonium oxalate. Now, there are times where we are going to need the Roman numerals and do the parentheses like we had to before. So let's do one more example like that. We have Mn. Mn is number 25. So it is a transition metal. It does need Roman numerals. Mn is manganese, not magnesium, manganese. And the OH is one of your polyatomic ions. No changing the ending. So hydroxide, we have manganese hydroxide, and then we need the Roman numeral there. We have to figure out what that is. Again, the math will always work. So we can say that we have 1 manganese. That's our unknown charge. We do not know it. But we do know that we have 2 of our OH groups. Remember, OH is 1 unit. It's one thing. So there's 2 of those because the parentheses tell us we have 2 OH groups. It's in the -1 column on your periodic table, and all of that has to add up to 0. So x minus 2 equals 0, and manganese has to have a Roman numeral 2 here in order to balance out the hydroxide's charge. And that's the end of this video. We're going to be practicing with this for a few days, and then we are going to get into writing out the formulas when we're given the name of it.